Homework 1.5, Quadratic Equations, Video 9. Homework due Saturday, May 16th, 2020 at 11:59 p.m. I left the quadratic formula up here, and also a recommendation in 1.5, you should try the remainder of the homework. But I want to go through two more examples. To A, show you different ways that the quadratic formula can conclude, and B, show you that the quadratic formula sometimes is not the most efficient approach. Well, let's start with this example, where we have x minus 5 times x minus 1 is equal to 1. Clearly not ready for the quadratic formula, not equal to 0, got parentheses where I don't need them. Remember, factored is useless if you're not equal to 0, if you're solving an equation. There are other scenarios where being factored is good, just not during solving an equation. So we're going to have to bust open the parentheses, get it equal to 0, and then get ready to use the quadratic formula. If we FOIL this, and I'll spare you the details, you'll get x squared. Pause the video, try to solve the problem. I don't just want to give it all away. But continuing, you would get negative 5x and negative 1x, which is negative 6x, and then negative 5 times negative 1 is positive 5 is equal to 1. And if we're going to use the quadratic formula, we need this equal to 0, which means we should subtract 1 from both sides. X squared minus 6x plus 4 is equal to 0. And at this point, we can get out the quadratic formula. For the sake of time and space, I'm not going to set up the quadratic formula using all the empty parentheses like I normally do. I'm just going to go ahead and write it. Negative b plus or minus the square root of b, which is negative 6. I'm sorry, I didn't even pause to announce who the a and the b and the c are. My brain's all over the place. I think it's time to go get lunch. In case you're wondering, 1:45 p.m. The a is 1, the b is negative 6, the c is 4. I mentioned that it's important to make that identification. You should do it before you start setting up the quadratic formula. So let's continue. Negative b plus or minus the square root of b squared, so negative 6 squared, minus 4 times a, which is 1, times c, which is 4, all over 2a, so 2 times 1. Again, there are 4 spots you can work simultaneously. The double negative here makes a positive. On the bottom, 2 times 1 is 2. And under the square root, let's figure out what's on both sides of it. Choose green. To the left of the subtraction is negative 6 squared, which is 36. To the right is 4 times 1 times 4. 4 times 1 is 4 times 4 is 16. 36 minus 16 is 20. We've run into the square root of 20 before. You can think how to simplify the square roots. If I ever draw a cloud like this, it's what I call a thought cloud, meaning you can think this and write down the result of it. But I can think of that as the square root of 4 times the square root of 5. And I know the square root of 4 is 2. So we get 6 plus or minus 2, square root of 5, all over 2. Because I couldn't do the square root, I can't combine the numbers on the top. But this fraction is just screaming to be reduced. I remember the rule for reducing a fraction. You cannot reduce parts of addition or subtraction problems. So nothing on the top is eligible to be reduced because I have an unfinished addition and subtraction problem. But you can bypass that by splitting it into 2 fractions with the same common denominator. So 6 over 2 plus or minus 2 squared of 5 over 2. Now both fractions can be reduced. And we get 3 plus or minus the square root of 5. So messy, yes. But I warned you that the quadratic formula, being a universal technique, will always get messy, sometimes really messy. Let's try this one. X squared plus 14x plus 50 is equal to 0. At least this one's ready. This one is already primed for the quadratic formula, but we should identify the a, the b, and the c. As usual, I invite you to pause the video, try to solve it on your own, and then come back and see if you get what I get. 1, 14, and 50. Ready to go. So if we set up the quadratic formula, big fraction bar. Negative b is negative 14, plus or minus the square root of b squared, so 14 squared, minus 4 times A times C, so 4 times 1 times 50, over 2A, so 2 times 1. Let's see what happens here. The negative 14 is precisely that. Downstairs is a 2. And by the way, you can anticipate some things. If I can't combine these, I can at least split them and reduce this to a negative 7. Under the square root, let's see what happens. Let's get the green marker again. Here's the minus. The left of it is 14 squared, which some people know, but if you don't, get out a calculator. 14 squared is 196. The right side is 4 times 1 times 50. 4 times 1 is 4, times 50 is 200. And 196 minus 200 is negative 4. So at least the number's small, but it's negative. Now why is that an issue? Well, in the quadratic formula, you simplify the square root as much as possible. And what's the square root of negative 4? Not 2, but 2i. And because of that I cannot combine the parts on the top. However, I can split this into 2 fractions and reduce. And I'll be honest, you can do the split part mentally and then reduce them instantly. I can reduce this and I can reduce this. Just make sure you reduce both of them. But if you split it into negative 14 halves plus or minus 2i over 2, negative 14 over 2 is negative 7, 2i over 2, the 2's cancel, and we get negative 7 plus or minus I. So the quadratic formula will get the job done, and it will be a task most of the time. Sometimes you're lucky and you get something like the square root of 57 and you shut it down. But I wanted to make one final point before we wrap up this series of videos. I know most students will just say, forget everything else, I'll just always do the quadratic formula. And honestly, the online homework for the most part won't know how you solved it, unless it asks you a question like what number completes the square. But here's the importance of having multiple approaches at your disposal. I could have solved both of these much, much faster without the quadratic formula. In fact, I could have solved both of them really fast with completing the square. If you're good with the quadratic formula and don't want me to go, man, why are you ruining a good thing? Go ahead and stop the video right now. Just learn how to do monkey see, monkey do, and don't worry about becoming a better math person, or more importantly, a better thinker. If there's anything you get from this class, it's how to think and how to solve problems. But when I'm looking at this, I know that completing the square is predictable and easy if this number is even, which it is. So watch what I could have done here if I had chosen to complete the square. I would move the 5 over by subtracting it from both sides. 1 minus 5 is negative 4. Completing the square is actually pretty easy if this is even. Take half of it and square it. Half of negative 6 is negative 3. Square it to get 9. I need 9 there. Add it to both sides. On the right side, negative 4 plus 9 is 5. On the left side, this is supposed to factor into something squared, and that something after the x is what you get when you take half of. Half of negative 6 is negative 3. Now I can finish this in one move. Because I square root both sides, which picks up a plus minus, and there would be a minus 3 here, which I would move to the other side, and now I got the exact same answers as before. Same thing over here. If I had started it from the beginning, you know what, I'll leave this here just for comparison. But if I had started this from the beginning, by completing the square, I would have moved the 50 over, make it negative. Take half of this and square it. Half of 14 is 7. 7 squared is 49. That's what I add to both sides. This will become x plus 7 squared. This combines to give negative 1. Hit both sides with the square root, and I'm really going to step on the gas here. Hit both sides with the square root. This becomes an I and picks up a plus minus. The 7 gets moved over, becomes a negative, and then I'm done. So honestly, completing the square when the time is right is so smooth and slick and gets to the answer a lot faster. And depending upon how fast you can solve a square root, solve using square roots, you can actually get through these fairly quickly. But if all you're concerned about is, let me just get the answer and learn as little as possible, then sure, get out the quadratic formula and use it every single time and drag it out much longer than you have to. All right. Sorry, I'm not really angry or upset. I'm just pointing out that the more you know, the more efficiently you can work and the less time you have to spend. All right, that's the end of this series of videos. I'll get them uploaded as soon as I can. Why am I saying that? Because by the time you see them, they will already be uploaded. Durr.